Right, so in the last video, there was the Stanford math problem. So yeah, in that, somewhere along the way this came up. So the perimeter of a figure is the diagonal squared plus 2 times the area. A perimeter squared over 4. Yeah. And we had to find the perimeter, and we had to do stuff. So when I was uploading the last video, it occurred to me that maybe this is a good generalization, so maybe we can do this for more figures. So it occurred to me, so yeah, let's simplify this for the rectangle first, right? So rectangle, right? For a rectangle we have, well, this equation. So let's just, p square is 4t square plus 8a, multiplying both sides by 4. Yeah. Okay, and then we can get an equation for, okay, so let's see, well, what would d square be? So p square minus 8a is 4d square. D square is yeah, p square over 4 minus 2a, right? And for a, so in area in terms of the diagonal and the perimeter is okay, so d square moves to the other side, d square over 4 minus d square. Does that make sense? No, wait, no, it's all of that over 2. I'm just writing the final forms here because I don't want to waste any time. So yeah, so we get p squared over 4 minus d squared, all of that over 2, so it becomes p square over 8 minus d square over 2. Does that make sense? I guess that makes sense, right? Okay, wait, let me just try it. So factoring out a 1/2, 2, yep, makes sense. That makes sense, right? That's for a rectangle, right? That's done and dusted. And now for a square, okay, so let's first visualize everything, right? So in a square, all of the sides are equal, all the angles are 90 degrees, and say we have a diagonal. Now this will call a, this will call b, and this will call d, right? So, oh, but of course a and b are equal by definition of a square, so we can safely say that both of these are a because they're equal, right? So in this case, well, I mean, we don't really care about these a's, right? We just want the perimeter in terms of the area and all that stuff. So okay, so what we'll do is, let's see, for a square, so for a square, first of all, okay, this is the rough things, right? These are rough things. So p, the perimeter of a square is 4 times a, right? And diagonal is root 2a. You can, that's by the Pythagoras theorem. And the area is a squared. Okay, let's see, how can we connect those? So okay, well, so a is p over 4 and a is d over root 2. So p over 4 is equal to root 2d over 2. I just rationalized that in my head, so we'll write that as p over 4 is, so p over 2 is, yeah, we'll do some cancellations there. So p over 2 is root 2d, right? That's good enough. Okay, now how can we make an equation for the area, right? Okay, so for area, okay, so we have square root of capital A is small a. So, and p over 4 is equal to square root of a. Okay, that makes sense. P over 4 is square root of a, and of course, um, p over 4 is no, wait, not p over 4. Now we know that p over 4 is root 2 over 2 times d, right? By this one. So we can safely say that, well, uh, yeah, square root of a is square root of, yeah, that. Okay, let's square it. Okay, let's try squaring both sides. Maybe that should help. So is 2d over 4, which is just d over 2. Okay. Wait, is that actually what? Am I doing something extremely wrong? D square over 2. Okay, thank goodness. Yep, for a second I really messed up in my head there. Yeah. And p over 4 is, yeah, okay, that makes sense. I'm just doing dimensional analysis in my head to correct the partially correct these things. Okay, so, well, I guess by that we can divide both sides by root 2. So 2 root 2 p over d's, I mean, yeah, I guess d by that one is simply, okay, you know what, let's get a good equation for p first. Yeah, I'm gonna just exchange some terms here and there, right? I'm not really changing much. It's more like 2 root 2d. Yeah, that makes sense. You know, does that make sense? Because, okay, yeah, that makes sense. Then the square root of a was p over 4. Okay, was it? Yeah, square root of a is p over 4. So squaring both sides, we get that a is p square over 16. Yep, a is p square over 16. Man, this is good for my reference. Okay, so, well, what's p in terms of a? Okay, so we have a in terms of d, a in terms of p. Okay, you know what, I'm gonna organize this a little bit. P square, okay, so yeah, just a little bit of organization is p square over 16 and d square over 2, right? And p in terms of a, okay, so p is what in terms of a? So 16a square root of a, okay, so p over 4 is square root of a, right? Yeah, so is it 4 root a? Yeah, that makes sense. And of course, and the diagonal is in terms of p, so p over 2 root 2, which is let's rationalize that. So something over 4 root 2 p over 4. That makes sense. I think that made sense, right? Yeah. And d is also equal to, okay, so d in terms of a now, right? So square root of root, yeah, square root of 2a, I guess that makes sense. Square root of 2a, and that's squared, done and dust. Yeah, so I guess that's pretty much it. I mean, yeah, I just thought that, having such, something is better than, just calculating everything again and again. So, yeah, this is mostly for my own reference. Yeah, probably. Okay, so let's see. Yeah, that's all, I guess. Yeah, if you don't know where this came from, check out the last video. It should be on the screen about now. And dab.